All right. So I'm Karri Huhtanen. I'm the founder and the CTO of Radiator Software, and the topic of my presentation is radios in action, securing, monitoring, and protecting network infrastructure. My presentation is, the contents of my presentations are as follows. We have here kind of different ways how radios can be utilized to kind of make networks more secure, how to kind of make them more resilient, and different ways how radios can be useful when you are setting it up in your, for example, networks there. We will first discuss a bit about certificate-based authentication, so replacing usernames and passwords with it. Then we will look into 802.1x and kind of VLAN-based network segmenting. We will then move on to the enhancing management traffic security with RadSec, which is radios over TLS. Then there will be this kind of a way how radios can be utilized to secure the actual network infrastructure device access. So how that can be secured with radios, TACACS Plus, and multi-factor authentication, for example. Then there is some kind of consideration given also for how to handle this kind of setups that where your internet connection is down. Do you still have an access to your network devices? Do you still have a working authentication? And that's the kind of topic of the ensuring network resilience there. And we will also look into a bit about how network monitoring can be enhanced with the radios authentication and accounting logs there. But let's go forward then. So these are the kind of different things that may have been issues in different networks. So usernames and passwords are getting harder to kind of secure and harder to use. It's easy to kind of fish a username for certain user, and if that particular user name and the password is something like an Active Directory, Enter ID, credential, they are kind of useful to kind of collect them and then utilize them to access some other systems there. So all these kind of things that if you can get into usernames and passwords and get them, they are easy to copy. You can get it from the users by phishing for them, and then you can just reutilize them in different cases. On the other hand, kind of having an access to the usernames and passwords, that's getting a bit harder in a sense that you cannot, for example, use something like challenge response protocols like MSSAP v2 with the something like an cloud interfaces like Enter ID. Instead, you need to utilize the username password. It's protected by only the TLS layer there. And if that TLS layer around TTLS or PEAP, if that is kind of broken, then it's easy to kind of also get that username and password from the request there. So usernames and passwords are kind of this thing that it seems that even the vendors like Microsoft and so on are trying to move away from. So getting into something like passkeys, multi-factor authentication, that is kind of more important to them nowadays. Then if we have a kind of network infrastructure where we have non-authenticated ports, we have a network that is completely flat, that is something that enables the attackers to both gain the access and then kind of move laterally in the network. And it's kind of minimal resistance and the risk of detection because they are not moving between trust boundaries like firewalls or routers or anything like that. So they cannot be catched with this kind of access control list or kind of a notice there if the network is completely flat and non-segmented there. The same thing is that if you have something like a warehouse, industrial place, or even your home office network, that you have kind of non-authenticated switchboards, it would mean that, okay, somebody who is able to gain physical access could then kind of connect to any port there and continue from there on, or maybe just to leave a small device in that network. Then if we move into the management kind of traffic, so like AAA, so authentication, authorization, accounting, this kind of unprotected radius traffic, that can also be captured, modified, and tracked if needed. And if you are sending this kind of traffic, for example, over internet, then it's kind of might be a good idea or might be valuable for somebody else to kind of try to collect that and try to connect that to particular users who are roaming around or utilizing things. We did have this blast radius a year or two ago, vulnerability in the radius protocol, but still this kind of radius requests are sent over the internet in kind of plain text without kind of any protection there. Multi-factor authentication, radius, and TACACS Plus, those can be used to secure network devices, but okay, what happens when if you are doing this as something like you are using this as a service that is kind of used over internet? What happens when your, let's say, this multi-factor service, or if you rely on Active Directory in cloud or on some other site than where you are? What if the internet connection is down and you are not able to access that? Do you still have any access to your network devices there on the site that is affected by this kind of thing? And in addition to this kind of control and this kind of authentication, authorization, radius is kind of source that can be used to provide information to monitor the networks better, detect and locate anomalies in the networks when combined with local analysis systems, maybe with artificial intelligence there. But let's lose first usernames and passwords, so replacing usernames and passwords. So like I said, usernames and passwords can be guessed, fished, copied, stolen. MFA adds some protection, but the user can be tricked to bypass it. This is called MFA fatigue, where the user is kind of bombarded with new MFA requests. If you don't have a protection against that kind of bombardment, the user might sometimes get frustrated and just accept the user to go in there. Also, this kind of MFA, it's not kind of really useful for this kind of repeating network authentication. So if you have something like VTA enterprise network or such thing deployed, kind of asking every time the mobile device wakes up from the sleep or if a laptop is opened, asking this kind of MFA verification for the authentication there. That's not kind of a very usable solution, or at least the users will get frustrated also with that one. This certificate-based authentication, which usually is TLS, that has been around something like 1999, and the IETF specification has been updated several times to include new TLS version and other enhancements. And here the kind of thing is that, okay, this has been around for a while, which means that there are a lot of mobile network devices or mobile devices that kind of already support this. And there are also radio servers that support this. So this has been kind of deployed and tested, and this kind of protocol, TLS protocol, that has been around for a long time. So it's kind of stable. You can utilize that to kind of authenticate your devices. Also with the modern devices, you have these trusted platform modules that where you can store, for example, the private key, so that the private key cannot be copied from the device. It's there secured in the security enclave of the device, and then only the certificate is transferred over the internet or over the connection there. So this way, it's harder to kind of get access to the private part of this credential and try to kind of copy that or get it phished or anything like that. So it's kind of more secure than the usernames and passwords. Also, for provisioning these certificates for this kind of managed devices, you can do this with different software and services, something like Microsoft Intune. You probably have some other solutions as well. There are some of let's say our partners like Secure W2 that are providing this kind of provisioning services and solutions for your devices. So there are already this kind of ways how to kind of handle also the delivery of those client certificates to devices. So this is kind of a good way to start getting away from the usernames and passwords. For non-management devices, this is a bit harder, but there are also kind of a need for the provision client certificates in some of the roaming networks like open roaming and so on. So this kind of provisioning solutions where it could come with the network profile or something like Apple configuration profile would include the client certificate. These are already kind of usable already now, so you can also utilize that kind of things to provision the client certificate to the devices. But that about the FTLS. One thing that I forgot to mention is that it can be used for both wireless and wired authentication, and we are actually moving into wired authentication next. So originally, when this was presented, this slide, I think there was Klaas Viering from EduRoam presenting EduRoam presentation there. So this is a reference for to his work there. I met Klaas first time in Zagreb in 2003, and there he presented the EduRoam, or more like the 802.1x and the dynamic virtual LAN selection in his presentation. So the idea was there that based on the authentication of the device, the username of the device would then be authenticated with the AP against radius, and what would be the user's like role in the user database. It could be then dropped in a separate network for that particular role there. And this is the kind of basis for this 802.1x technology there. And that one can be used. It was already usable then for the wireless networks, and it's usable also for wired networks. So what can be done with it is this kind of network segmentation. So based on the device MAC address, it can be device authentication. It can be kind of dropped into different virtual LANs there. If it's using wireless, that can be done with the most Wi-Fi controllers and APs. If it's using wired, also most enterprise switches, they have this feature that based on the authentication there against the radius server, the user can be kind of be directed to be dropped in a certain kind of network there. And because we have this kind of different virtual LANs, they are usually used for this kind of segmentation of the network in any case. So when we talked about flat networks without segmentation, when we have this kind of segmentation where we have something like an IoT and OT networks in different networks, we have the office computers in other networks, and we keep the guests in their own network. This kind of enhances the overall network security there, because now we don't have a flat network, and to kind of access something like from office to IoT or operational technology networks, then you will likely need to go over trust boundary like a firewall, that kind of device. So that access from the office to OT can be, for example, controlled with the firewall and the routing there. And the whole thing here is that the decision which VLAN will be given to the user can be done in the Radius server, and it can utilize the different sources to kind of make the decision that which virtual LAN that user or device can be connected to. So combining this kind of a multiple sources of information is also possible with the Radius there. It can probably do even AI in some phase. Even if it doesn't do it already, it can probably ask in the future that, okay, based on this all information I have received in the authentication and accounting requests, what a network should this user be allowed to connect to? And it can do, this can be asked from a separate system, this device security assessment, and of course we get a lot of information from the Wi-Fi controllers about the devices as well. All right. Then moving on into the securing the actual Radius traffic there. So here is, for example, this kind of setup that there is organization here using Radius over the internet. It might have this kind of service provider Radius servers. If it uses non-encrypted Radius over internet, the bigger the distance is between the, let's say, the actual Radius clients and the service provider Radius servers, the more, of course, opportunities there are to kind of collect the traffic or kind of analyze that there. And also if there is if the Radius service or the Radius clients have not been updated to kind of have a plus Radius fixes in them, it means that the risk is also larger to leak the information, or the traffic can be kind of collected without the devices kind of noticing it. The larger the kind of the path from the Radius client to the server is. The solution for this kind of is, of course, kind of utilizing some encryption around the Radius traffic. There are plus Radius mitigations or this kind of fixes that add this message authenticator attribute, but those don't kind of add any security for the Radius request itself. So the Radius request itself still has this kind of plain text information in it, and it also secures, for example, the passwords or that kind of thing only with something like basically in basic Radius authenticator with protocol, has protocols like MD5 and so on. So it's not kind of a very secure in any case to transfer any information over the internet without using something like Radius over TLS, RadSec to protect that traffic. What we have noticed, because we have done RadSec since the start of the that draft, actually Open System Consultants, the original developer of the Radiator and the Radiator 4, the bell-based Radiator, the original developer was one of the authors in the RadSec Radius over TLS draft, and that is why we have a kind of collected a lot of kind of experience of utilizing that RadSec in different environments. And we have noticed even better, let's say, authentication accounting traffic throughput with RadSec than with Radius over UDP with our new Radiator 10 based RadSec servers there. Also, one thing to note about this is that if we here have something like a larger network and we have a lot of different Wi-Fi APs or different radius clients behind one IP address here, that means that if we use something like an old radius protocol, these services kind of need to distinguish the actual radius client based on something like radius attributes, because they cannot rely on the IP address there to kind of identify the particular radius client. But when we are using something like RadSec there with client certificates, we can utilize those client certificates to identify any client, even behind this network address translation and behind dynamic addresses. So we can provide also here in the service a better access control, a kind of better authentication that who is actually connecting to us. Then about protecting the actual network infrastructure access there with radius. Most of the devices in an enterprise network, they have a support for this kind of authorization with radius. Some of them have it, they use radius attributes and radius protocol for that authorization. So when somebody tries to log in, for example, to a switch device, the switch device can then ask from radius service that, okay, first, for example, the authentication, the username, password, also modern credential, and then also that what kind of access should be given to this particular user. And then we have here a radius server that can combine the information from Active Directory Entra ID for authentication, for authorization, for example. It can check that if this particular user belongs to something like an administrators group, or is it a help desk user, or so on. And it can also add some other kind of third-party information. It can, for example, after the username password authentication, also run this kind of second verification that the user needs, for example, to click something in their multi-factor authenticator app that, yeah, I'm really trying to log into this network device, and so on. So it can be added, it can add this kind of extra layers of protection, how to kind of log into the actual network devices there. TACACS Plus is just a separate protocol that can transfer also this kind of more authorization information in the request, but it can be used in parallel with radius, and it can be combined with all of these kind of setups that we will first check the username and password from certain location, and then we will still check this kind of, let's say, multi-factor authentication there. Also with something like Radiator radius server, you can run this kind of two-factor radius authentication like TOTP or HOTP. These kind of standard protocols utilize any authenticator app that supports this and run the whole two-factor authentication in one Radiator radius server there. You don't have to kind of set up or buy a different service. You can do also this kind of multi-factor authentication with the Radiator server itself. Some more things about this. Well, we already talked about how the network devices can authenticate and authorize the users. And the benefit of this is, of course, that there is no need for common user pass accounts. You can have something like a, let's say, bank vault user accounts and passwords when you don't if you don't have an access to this centralized authentication service. So you might put something like your these kind of emergency or backup username passwords in the sealed envelope in some bank vault or that kind of thing, and keep them there and use them only for emergency. So you don't need this kind of common user accounts that have the, for example, something like common username and common password known by, for example, the whole IT staff there. And when one person from your IT staff moves into a different company, are those passwords or credentials ever resetted if they are common ones? Instead, you can kind of have this kind of multi-factor authentication there, and then you don't have the need for common user accounts, and you can always revoke that token from the user. You can revoke that multi-factor token, remove the user account, and then you can kind of have a better control that who is actually allowed to log into your network devices there. And of course, the multi-factor authentication, it replaces the passwords with more secure authentication. So no need for this kind of weak passwords that the user might set there. I already talked about the combining of this information. And like I said, this is kind of common protocols, common practice, common architecture. So all of this works with most enterprise operator and even operational technology network devices. So also this is a bit of kind of older stable technology that can be used with the radio servers to kind of make your networks more secure there. There is also kind of increasing support for securing the connections where the devices connect to the radio server or TACACS Plus with TLS for added security as well. All right, but then you have all these kind of great things set up, but what happens when your internet connection or cloud services are down? So if you rely on that you have there nice cloud service, but it's behind the internet. So your devices here, your workstation, servers, services, switches, routers, they utilize something like a cloud-based Entra ID, LDAP radius, or multi-factor authentication service, and your internet connection goes down there. Can you log into your workstation, servers, network devices to do the diagnostics? Do you need to kind of rely on this kind of emergency support accounts, those that I mentioned, those bank vaults or sealed envelope accounts, to kind of securely configure network devices? But if you, or what if your kind of user account management is based for a local Active Directory or that kind of solution, and something like a ransomware or faulty updates hit your directory and other servers? Do you still have some way to kind of start recovering from that problem, or do you need to kind of set up the directory service up again to kind of get into those network devices there? For this, there are different ways to kind of try to kind of add some resiliency for networks there. Of course, you can have something like an on-site AAA. So basically, the idea can be that you can combine the centralized AAA that is, for example, used over internet, and still have burst local on-site AAA there to kind of be the first step there. So you don't always have to send those requests to the centralized AAA over the internet. But for example, if this kind of failed connection, failed internet connection happens, then you have on your site, you may have still this kind of a fully functional local AAA. So idea here is that in this kind of setups, even if you would have in a normal case this centralized AAA used, you would then have some kind of ways to synchronize the credentials or the tokens from that centralized AAA for that kind of situations where your connection breaks. And if you use certain authentication protocols like TLS and the certificate authentication, if you don't have to ask any additional authorization information over the internet or some other location that is not on site there, then you can just rely that, okay, client certificate authentication works, and you still have a working, let's say, network connection inside your site there, even if you don't have the internet connection to the centralized server. And of course, you can then even secure that connection if you need that one from site to centralized AAA by using something like a radius over TLS RadSec there. MFA can also be implemented without this kind of cloud services because those token and that token information can be replicated, for example, in a SQL database or SQLite database, even from synchronizing them from the centralized AAA. And when this kind of connection here is failed, then you can still continue using multi-factor authentication if you have synchronized the kind of token database from the centralized system there. So this is the kind of just an idea how, for example, you could add more resiliency for your networks so that you don't have to kind of rely on the cloud or internet access to kind of everything to work there. Then moving on into the how Radius can provide more information about the network devices and what is happening in your network. There is on the left side, that is our Radius authentication log that is sent by Cisco VLC about this kind of a Wi-Fi network authentication there. And we can notice that Cisco sends, for example, more information in their vendor-specific attribute, Cisco AVP there. They can send something additional things that are not usually sent with the access request, like the IPv address or VLAN IDs or other kind of profiling information in their vendor-specific attributes there. And this information is often included in the Radius authentication as well as an accounting request and can be utilized also for making these kind of AAA decisions or log, for example, for further analysis. And if we think about this kind of information, what you can collect from the Radius attributes, that could be sent into something like log analysis system, CMs, XDR solutions, or even be sent to AI that, okay, what's happening in my network? Are the users authenticating there? How long does it take for them, for example, to get the authentication done? And this kind of information can be used to kind of improve the, let's say, user experience, get the more information that how well the, for example, network authentication is working and so on. There are also this kind of additional attributes like chargeable user identity that can be used to kind of connect the authentication and the accounting request to a particular user, because we may have in the roaming user where the username, the only username we can see here is something like anonymous at Realm there. So we don't know who the actual user is. And now when the most devices also support MAC address randomization, we don't have this kind of, let's say, tag or any kind of way to kind of connect that who this particular, well, we don't have that who in any case, but we don't have this kind of a way to kind of distinguish, for example, if there are multiple anonymous from our company kind of joining to your network, you cannot kind of connect who is there if the MAC address is changing there, or you can't pinpoint that particular device from the each other there. And that's why there are, for example, this kind of radius attributes like chargeable user identity request, where the idea is that when the user is authenticated from something like our organization, then we send back this kind of chargeable user identity, so that you can kind of then have some kind of handle that when you are coming to talk to us about that, for example, this user did something bad in your network, then it's also easier for us to kind of check the logs and pinpoint that, okay, this was actually the user. So this can be used for this kind of tracking without kind of making the user's privacy worse there. Then still continuing on this issue, this one is updated from the Radius conference presentation there. And here I added all those screenshots on the black background there, because I wanted to emphasize this kind of thing, that some of the information you might want to kind of collect from your network devices and from your network, it's not always in the authentication request. It can be also in the accounting request. So this is a kind of examples of the information that is in the accounting request, but isn't in the authentication request. So for example, something like if we are using IPv6 in our networks, the device can have multiple IPv6 addresses. It can have a link local address there, and it can have something like address generated from its MAC address. And nowadays, it can also have this kind of temporarily private IPv6 addresses, and there can be a lot of these different addresses depending how long that particular device has been in the network. And all this information is usually only in the accounting requests. And if in the accounting request we have username there, and it would be something like anonymous@radiatorsoftware.fi, of course we cannot kind of connect to that who was this anonymous there, and we cannot kind of tell that, okay, this has this kind of chargeable user identity, and ask for kind of additional information about that. So that's why it's kind of important to kind of have this kind of, let's say, chargeable user identity IDs there, to kind of that it's easier then to do diagnostics. It's easier to kind of pinpoint that, okay, in one particular time, this is the user that we are interested in. We may not know the identity of the user, but at least we have some kind of handle or tag to that user that we can kind of give, for example, to authorities to then to kind of continue some investigation and so on. The thing about this is that there is also a lot of other information collected by the network devices. So the third example here is what is kind of given in the accounting request about this device by the Cisco wireless controller. So it can do, for example, some kind of identifications and classifications that, okay, this is a Linux workstation, something about the HTTP user account that is using, and also this kind of additional information. And the thing about this is that this is probably useful when it's in your own network, but would you like to kind of send the same information to somebody else over the roaming there? This is something that you need to kind of consider, that maybe in the border of your network, you might want to kind of filter that you won't be giving some other organization the information which wireless LAN this user was connected to, or was it using Linux or Windows, or what kind of device was that. And this kind of protecting privacy is also this kind of thing that needs to be kind of considered, at least with the roaming networks, when you get this information. So this is useful information for you to kind of keep your network secure, but you shouldn't perhaps share it over the borders of your network there. And like I said, this kind of randomization of MAC addresses and these privacy features that are kind of increasing in the mobile devices, they kind of also push that okay, privacy is good, but in sometimes we need that kind of some way to kind of distinguish the users from each other, so that we can then kind of also handle this kind of security issues or incidents properly there. And for that, Radius already has this kind of solution, but this information needs to be logged and it needs to be collected to kind of for that to be useful there. In conclusion, what can Radius do for you? What we can do with Radius? We can already do stronger authentication than the passwords there. We can utilize Radius to kind of effectively segment and secure the network access, and that segmentation can then be prevent this kind of unauthorized lateral movements between the networks there. We can secure the Radius traffic by using Radius over TLS RadSec, so we can protect sensitive Radius communications from interception and modification, and we can actually then identify those network devices behind network access translation, for example, easier there, that are these really our network devices that should be allowed to connect to our service or servers. We can protect, with Radius, we can protect the infrastructure as well. Combining the Radius, TACACS Plus, multi-factor authentication, then we don't have to use those common usernames and passwords. We can then have this kind of more secured access to the critical network devices. Depending how we set up these Radius servers, if we do database replication, if we utilize FTLS, if we don't do this kind of authorization, authentication request against cloud services, we can make more resilient network operation with that kind of solutions there. Then if we kind of collect information about the Radius authentication, Radius accounting logs, we can kind of leverage that information to enhance network monitoring. We can get more security insights, and we can do anomaly detection with that. We can combine it, for example, something like sending all that information to the Elasticsearch, different kind of solutions there as well. But that was my presentation this time. Do you have any questions, comments? Let me check the chat if there is anything there.
Okay, thank you, everyone. If there is anybody who wants to ask something, now is the time. And we can also turn out the recording now, I think.
Yeah, let me do that.